I hope that we are all doing well. Hope everything's going fantastic in the world of whatever it is that you are doing or whatever it is that you do. Let's get some music going on up in here. I always think that I have it set up and then it's never the way I think it is. There it goes. Cool. So what we're doing today is IPv4 addressing part 1. Okay? So, oh, I need to get my drawing tablet. This can get pretty confusing. So we are gonna listen to it not at 1x speed, but we are gonna listen to it at 1.5, or no, sorry, 1.25 speed. It's a long one, okay? There's probably gonna be a lot of breaks that are gonna go on in here, like breaking things down. If you have any questions at all, just pop into the chat. I have text to speech on, so I should like hear it as we go on. So yeah, let's go ahead and we are gonna dive directly into this. Here we go.
To Jeremy's IT Lab. This is a free, complete course for the CCNA 200-301. If you like these videos...
And then we are also going to do the Anki flashcards for day 6 and 7 today, because we didn't really do them last time because I had to go.
Please subscribe to follow along with the series. Also, please like and leave a comment and share the video to help spread this free series of videos. Thanks for your help. Also, remember to download and use the Anki flashcards with the link in the description, which will help you very much in remembering what you have learned. Let's get started. This is the 7th lecture in the series. In the past couple of videos, we talked about Ethernet LAN switching, for example within this small network of PCs attached to a switch. In this video, however, we'll start to expand our horizon and take a look at how traffic is forwarded not within a LAN, but between different LANs. Basically, we are going up the OSI model from layer 2, the data link layer, to layer 3, the network layer.
Okay.
Let's do a quick review of layer 3. This slide is from day 3's video on the OSI model. Let's review some characteristics of layer 3, the network layer. The network layer provides connectivity between end hosts on different networks, outside of the local area network. Layer 3 provides logical addressing, specifically IP addresses. Where layer 2 uses MAC addresses, which are assigned to the device when it is made, IP addresses are logical addresses you assign when you configure the device. Layer 3 provides path selection between source and destination. Over larger, more complex networks, for example the internet, there can be many different possible paths to a destination. Selecting the best path to the destination is part of Layer 3's functionality. Routers operate at Layer 3. So far in this course, we haven't talked much about routers. That's going to change over these next few videos, however, as we talk about Layer 3. In this video, our focus will be specifically on the logical Layer 3 addresses, IP addresses. You may recognize this network from the previous videos on Ethernet LAN switching. These PCs are all connected by switches, so they are part of the same network. These Layer 2 devices, switches, do not separate different networks. They connect and expand networks. I could connect 2 more switches, each with multiple PCs connected to them, to this network, and it would still be one network, one LAN. Because of this, the PCs all have IP addresses in the same Layer 3 network, 192.168.1.0/24. PC1's IP address is 192.168.1.1. PC2's IP address is 192.168.1.2. PC3's IP address is 192.168.1.3, and PC4's IP address is 192.168.1.4. If PC1 sends a broadcast frame with a destination MAC address of all Fs, after switch 1 receives the frame, it will broadcast it out all of its interfaces except the one it was received on. So that means G01 and G02. Switch 2 will then do the same with the frame, broadcasting it out of all of its interfaces except the one it was received on. So that means G00 and G01. As you can see, all other PCs in the network have received the frame. Now, what if I put a router between switch 1 and switch 2? Now I've put R1 in between the 2 switches. Now instead of one network, the PCs have been split into 2 networks. Let's say switch 1, PC1, and PC2 are still on the one.
You could very easily say that like this is Office 1 and this is Office 2. So that would make this gateway right here that would make this router right here their gateway out to the like actual world. So you could think of it like these are apartment complex. Like this whole thing is an apartment building in an apartment complex. This is an apartment building, an apartment complex. And then this is the mail room in the entire apartment complex, because they could probably send like messages to each other, no problem, within the apartment. Maybe using the office would be a better terminology, but either way. And then the main mail room that can go outside of the network, outside of the local, and into the WAN, the worldwide.
192.168.1.0/24 network. But now switch 2, PC3, and PC4 are on the 192.168.2.0/24 network, with PC3 being 192.168.2.1 and PC4 being 192.168.2.2.
Just so you know, he's probably not going to talk about it, but this /24, that's a side R, or I don't know how you read it. It's just an acronym. I don't remember what it stands for. Basically, it's shorthand for the subnet. And we'll talk more about how we can divide up IPv4 addressing. I also have a lot of questions when it comes to IPv6, because if IPv4 is supposed to be like getting phased out, like we sure do have a really strong infrastructure for it. Also, there's no reason for it to be phased out if its main purpose now is private networks. You know what I'm saying? I don't know. Maybe I don't understand it enough yet.
You may have noticed that in these network IP addresses, the first 3 groups of numbers, 192.168.1 and 192.168.2, represent the network itself, and only this last 0 changes to represent the end hosts on the network, the P.
That is so important. That took me so long to understand that this is the network itself. Nothing is on this. Everything is on this. So devices are this number. This is the, like, I guess the label you could say it as.
PCs. You may.
And it's not only limited to these 3. It could be just this. I almost said hexadecimal. This crap. I can't remember what it's called. But these numbers, or this one, or it could be this one. Okay, it could be all 3, just 2, or just 1. I cannot remember for the life of me what this is called. Octet. Nailed it.
Also have wondered what these /24s mean at the end. Actually, they are used to tell what part of the address represents the network and which part represents the end hosts, the PCs. /24 means that the first 3 groups of numbers represent the network. In this video, I'm going to go in depth about how these IP addresses work. But first, there's one more thing missing in this network diagram. The router needs an IP address. Actually, not just one IP address. It needs an IP address for each network it is connected to. So let's give R1's G00 interface an IP address of 192.168.1.254, and its G01 interface an IP address of 192.168.2.254. This time, if R1 sends a frame to the broadcast MAC address of all Fs, switch 1 will receive the frame, and it will forward it out of all interfaces except the one the frame was received on. So it sends the frame out of G01 and G02,
yes,
and PC2 and R1 receive the frame. However, that's where it ends. The broadcast is limited to the local network. It doesn't cross the router and go to switch 2, PC3, and PC4. I'll go more into detail about routing and layer 3 forwarding, but as I said, this video will focus on IP addresses themselves. So let's take a look. This is a chart from Wikipedia showing the IP version 4 header. IP, or Internet Protocol, is the primary layer 3 protocol in use today, and version 4 is the version in use in most networks. As you can see, there are a lot of different fields in the IPv4 header, more than in the Ethernet header. We'll talk more about the IPv4 header in another video.
Okay, so this is the first octet, second. Okay. Okay, I understand this based off of what we did with the understanding the frame and the packet last week.
So today let's look at these 2 fields, the source IP address and destination IP address.
Yes.
These fields are both 32 bits in length. As you can see, they stretch from 0 to 31 in this chart. So IP addresses are 32 bits, or 4 bytes, in length. Let's take a look at this IPv4 address, 192.168.1.254. An IPv4 address is 32 bits long, so each of these 4 groups of numbers represents 8 bits. 192 represents 8 bits, 168 represents 8 bits, 1 represents 8 bits, and 254 also represents 8 bits.
Yeah, they're all octets.
If we write these 8 bits out as ones and zeros, 192 is 11000000, 168 is 10101000, 1 is 00000001, and 254 is 11111110. This way of writing numbers using just zeros and ones is called binary. However, binary is difficult to read and understand for us humans, so IP addresses are written using what's called dotted decimal, because there are 4 decimal numbers, 192, 168, 1, and 254, separated by dots or periods. Let's spend some time learning about binary, which is important to understand IPv4 addresses. Before looking at binary, let's review decimal and hexadecimal. In decimal, also known as base 10, each digit increases by a factor of 10. For example, this number, 3,294, consists of 1 unit of 4, 9 units of 10, 2 units of 100, and 3 units of 1,000. Notice that they increase by a factor of 10. 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, and next would be 1,000 times 10, which is 10,000. Now let's look at this number in hexadecimal. Decimal 3,294 is written in hexadecimal as CDE. How does that work? Well, the first digit represents ones, so this is E times 1, and E is equal to 14, so that equals 14.
Yes, we remember that from last time.
The next digit increases by a factor of 16, and 1 times 16 is 16, of course, so this is D times 16, and D in hexadecimal is equal to 13, making this equal to decimal 208. Finally, the next digit increases by a factor of 16 once again, and 16 times 16 is equal to 256. So this is C times 256. In hexadecimal, C is equal to 12, so this is equal to decimal 3072. If you add those numbers up, you get 3,294. So that's a quick review of decimal and hexadecimal.
Okay, give me a second. I need to process what he just did. Okay, I understand how we got the letters. We got the letters because A is 1 and D is 2. Okay, I understand that. What I don't understand is where we got the 16 from. Base 16. I don't understand anything you just did. I'm sorry, guys. I'm slow.
Before looking at binary, let's review decimal and hexadecimal. In decimal, also known as base 10, each digit increases by a factor of 10. For example, this number, 3,294, consists of 1 unit of 4, 9 units of 10, 2 units of 100, and 3 units of 1,000. Notice that they increase by a factor of 10. 1 times 10 is 10, 10 times 10 is 100, 100 times 10 is 1,000, and next would be 1,000 times 10, which is 10,000. Now let's look at this number in hexadecimal. Decimal 3,294 is written in hexadecimal as CDE.
Okay, that makes sense because 1 is A, so that would be 2 is D. So A, B, C, C is 3, A, B, C, D, E, F, G, 8. What? So then why is 9 E? We might be going to our friend here in a second. Okay.
How does that work? Well, the first digit represents ones, so this is E times 1, and E is equal to 14, so that equals 14.
How is E equal to 14? Okay, so A is equal to 0 because it restarts. In case you didn't realize, we have to start with 0, otherwise we lose a number. I know that sounds really stupid, and it's hard to understand, but just accept it in your heart. Okay, so then it just repeats itself because there's only 10 real numbers, 0 through 9. So 1, 2, 3, 4. So then why is D 2? Because it should be 200? I don't understand. I thought I understood. Because based off of this chart, E is 14, but D is 13. So hexadecimal. Okay, hold on. Dang, that's not what I wanted. No, dude, I hate when my screen does this. That's gonna ruin the whole stream if I have to turn off my monitor and turn it back on. Oh, that's exactly what it's doing. Okay, hold on. I gotta turn off my... I have to restart my monitor. Not my computer, just my monitor. I have no idea what that's gonna do to the stream. So, buckle up. I hate when it does this. Just sometimes it gets like glitchy and it just has to be turned off and turned back on again. Alright. So now let's look at this. Decimal and hexadecimal are two different ways of writing numbers. Decimals are normal number system, 1, 2, 3, 4, 5, 6, 7, 9, based off of 10 because we count 0. Hexadecimals is based off of a lot more computer network things. So it has 10 and then A, B, C, D, F. So it's based off 16. So A is 10, 15 is F, so on and so forth. Okay, that all makes sense. I understand this. So what I don't understand is... Okay. Okay. Then explain this to me. That one's going to take a little bit for it to cook. They are the same value, just written in two different systems. Decimals is power of 10. Analogy... No, I understand, like, I understand the concept. I just don't understand how that is working. So that's going to be 1, 10, 100, 1,000. So that'd be 4, 90, 200. Then you add them together. So then it's based off of 16. So then the hexadecimal CDE. C, D's 13, so why did it say it was 2? So it has to be above 1500, which is what we talked about last time. Okay. So in the screenshot, how is D2? So it's still based off of the same thing. 16. Because 16 to the power of 3 is 256. Is that right? 16. Where's the stupid caret key? To the power of 3. No, not even close. Is not to, in the screenshot, d equals 13. That is not. Oh, maybe because I'm connecting it between these.
You get 3,002.
E equals 14, D equals 13, C equals 12. So then where did the 116 and 256 come from? Okay, and this set, dang it. Decimal and hexadecimal are just different number systems. The slide is showing that the hex CDE and decimal 3,294 are the same value because CDE is 12 times blah, 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 blah. Okay. All right, what we got? The 116 is going to come from the fact that is based off of 16. In any number system, each position has a value. Oh, I did the power of 3. So the power of 2 would be 256. So it's following the same rules. Power of 1, power of 10, power of 100, power of 1,000, power of 1, power of 16, double the 16, and so on and so forth. Okay, which is why it says it's based off of 10, why it says it's based off of 16. This is all making sense. So now what I don't understand is, which is the last thing I don't understand. What is this? What? 1, 2, 3. Interesting. Counting hexadecimals on your fingers. Okay, we might come back to that. So then what is the point of the... So then what's the... Come on, dude, type. So then what is the point of CDE? So then what's the point of CDE? Yeah, convert the letters 12 to C. Okay. It's all starting to make sense. Simple answer. The point of CDE is just to show an example of hexadecimal number. It is not a special networking value by itself. Jeremy is using the CDE because it contains letters. It shows you how to use hexadecimals. CDE is a hex number, and the slide shows, okay, blah, blah, blah. Analogy, think of CDE like a practice word. Okay. Like in music class if you write. Use the paradiddle. Yay.
294. So that's a quick review of decimal and hexadecimal. Now let's look at binary. So looking back at this IP address, 192.168.1.254, let's look at how each of these numbers is written in binary, starting with 192, which is 11000000. Binary is base 2, meaning each digit increases by a factor of 2. It doubles. So that means that this 11000000 really is 0 ones, then 1 times 2 is 2, so 0 twos, then 2 times 2 is 4, so 0 fours, then 4 times 2 is 8, so 0 eights, then 8 times 2 is 16, so 0 sixteens, 16 times 2 is 32, so 0 32s, 32 times 2 is 64, so 1 64, And 64 times 2 is 128. So 128. If you add 128 and 64 together, you get 192. Next, let's look at how 168 is converted to a binary, which is 10101000. So 10.
Yes.
101000 in binary means 1 unit of 128, 1 unit of 32,
And then you add them
and
together.
1 unit of 8. 128 plus 32 plus 8 is equal to 168. Next up is 1, which is the decimal representation of binary 00000001. This is pretty simple. 1 is equal to 1 unit of 1. Let's go to the last 8 bits of the IP address. 254 is equal to 11111110 in binary. Let's take a look. Binary 11111110 represents 1 unit of 128, 1 unit of 64, 1 unit of 32, 1 unit of 16, 1 unit of 8, 1 unit of 4, and 1 unit of 2. Add those all together, and you get 254. So hopefully you have an idea of how binary works now. Before we do...
Okay, so everything is an octet, so it has 8 bits in it. Each one of these numbers represents it doubling. So 1, 2, 4, 8, 16, so on and so forth until we get to 128. So 2, 4, 8, 16, 32, 64, 128. Where you can get in trouble is if you accidentally flip this. You got to remember the big number goes on the left. I always remember that by left. Right's always right, so go left. So okay, there was something else with this.
Do some practice converting between decimal and binary, I want to teach you one more term. You'll often hear each of these 8-bit groups referred to as octets. Now let's get some practice converting binary octets to decimal. Here's an example. We have a binary octet of 10001111. How can we go about converting this to decimal? First...
Okay, hold on. We're going to do this by ourselves first. Wait, my pen gonna reach over there? No. Okay. So it's 11110001. Okay, these are all supposed to be ones. Not just dashes. Those are crappy ones. Anyway, so this is 1, 2, 4, 6, 8, 16. Why did I say 6? 8, 16, 32, 64, and then 128. So then we add those up. So we're going to add 128 plus 8 plus 4 plus 2 plus 1. So 8, 9, 10, 11, 12, 13, 14, 15. 15 added to this. That's going to be 13. Carry the 1. That's 2, 3, 4, and 1. So the answer is 143. Right? Yeah? Are we following? We following that?
I recommend writing the value of each binary digit over the binary numbers. You can start with 1 on the right,
hey, that's
and then
what we
multiply
did.
by 2 for each digit as you move to the left. Or, if you prefer, start by writing 128 over the digit on the left, and divide by 2 as you move to the right. Once you have written these values, simply add up the value of each one, and you get the answer. 128 plus 8 plus 4 plus 2 plus 1 equals 143. So, binary 100001.
We did it, boys. We did it.
111 is equal to decimal 143. Let's do another example. Now we have binary 01110110. Once again, write the value of each binary digit over the octet.
Okay, so we should be able to do this one pretty quickly. So we have 2, 4, that's 6, 6 and 16, that's 2, that's 24. Or sorry, that's 20, 22. 22 plus 32, that's 4, that's 54. 54 plus 64, that's 8, that's 118.
So we have 1 unit of 64, 1 unit of 32, 1 unit of 16, 1 unit of 4, and 1 unit of 2. Add each of those numbers together, and you get the answer, which is 118.
I did that all in my head.
Binary 01110110 is equal to decimal 118.
Basic addition.
What is binary 11101100 in decimal? This time I won't display the value of each binary digit above.
Okay, so we have 1, 2, 4, 8. So 4 and 8 is 12. 12 and 32 is 48. 48 and 64. Oh, this is getting difficult. Is 2. Crap, I lost the number. Damn it, I lost the second digit. Okay, let's try it again. So 1, 2, 4, 8. 4 and 8 are is 12. Yes, 4 and 8 is 12. 12 plus 16. Is that right? Yes. Is 28. 28 plus 64. 28 plus 64. So 8 plus 4. No. 28 plus, 8 plus 4 would be 12. Carry the 1. That'd be 3. 3 plus 6. 9. 92. Plus 256. 6. God, I suck at math. 256 plus 92, right? So that would be 8. 5 and 9. You means minus 1. 4. Carry the 1. 248.
Above.
I feel like that's
Write down
wrong,
the number
boys.
yourself,
I feel
or
like
try to do the calculation in your head. Pause the video to figure out the answer.
I just did. Give it to me, Jeremy. I need to
Got
know.
it? 128 plus 64 plus 32 plus 8 plus 4 equals 236.
Was that my answer? I don't even remember what my answer was. I remember 6. I remember 200. I don't think my digit. Well, I'll have to check the VOD. I don't remember if my digit in the middle was correct. But I think we understand
we'll do some
the
more
concept.
binary to decimal conversion practice in the quiz for today's video. Let's move on. Now let's try converting in the opposite direction, from decimal to binary.
So the way we're going to do this is, let's see here. Can I erase this? Yeah, erase it. That's what I'm talking about. Okay, and then go back here. So then we're just going to do the exact opposite. So we have 2, 50, 6, 64, 32, 16. It's just music. It's just like, that's all it is. 8, 4, 2, 1. So we can't use 256. So we're just going to put a big old 0 right there. We don't need that one. We do need 64. So the way you can do it is we'll go over here. And there's 2 ways to do it. You can just add them or you can just subtract it. So 64, subtract Gotta borrow. That now becomes, actually I don't need to scribble out. I can just, that becomes 1. That's an 11. 11 minus 4, 1, 2, 3, 4. That's 7. Minus that, take away this, which becomes not a squiggle but a 1. So 11, that's 5, because 5 plus 6 is 11. And then now we have 156 left. So obviously we need 32. So another way we could keep doing this, right? Or we could just add it up. 64 plus 32, that would be 6. That'd be 92, 96, right? So then we just keep going. Let's see if we can keep going. We'll continue subtracting. So 16, we gotta have a 16 in there. And you just keep going until you can't go no more. So that would be 1, that would be 4, that would be 1. I did this wrong. 32. That would be 5. That would be 2. That would be 1. 16. 1. 15. That'd be 9. Yeah. 9. That's 0. That's 1. I think I fucked up. Let's pretend that didn't happen, boys. I just impressed y'all with my amazing math skills with addition, and then I just proved to you that I can't go backwards. I can only go forwards because my life is only ever moving forward. You know what I'm saying? You know what I'm saying? Okay, here we go. We're just gonna add these up because I'm so much better with addition. Okay, 64 plus 32 plus 16. I feel pretty good about those numbers. I also feel good about 8 as well. This is an 8. So 4 and 6 is 10. 10 plus 2 is 12. 12 plus 8 is 20. 6 plus, or 1 plus 3 is 4. 4 plus 6 is 10. 10 is 12. Did I do this right? Okay, let's stop watching.
Have the decimal number 221. How can we go about converting it to binary? I recommend writing out the values of each bit in the binary octet,
easy. You just
like this.
count them up, and then I just proceeded
Then, starting from 128,
with
try to subtract
math.
each number from the decimal number you're trying to convert. As you can see, we can subtract 128 from 221. So write a 1 under 128. Now we've got 93 left. Can we subtract 64?
Damn it! Why did I think that 121 was greater than 221 was greater than 256? That was stupid. Oh my god. That's why my shit wasn't working out. Okay. Boys, we're going to try this again because I'm an idiot. Okay? So, boom. Here's 1. I am studying for CCNA. So let's do this. 256, 221. 6 minus 1 is 5. 5 minus 2 is 3. That leaves us with 35. So that means we're going to have a 0 here. And then we're going to have a 1 here. Okay. I do have some prior experience. I've already taken CCNA 1, 2, and 3, but it was a while ago, so this is really just a huge review session for me. Subnetting is challenging for sure. I actually was just talking about how I don't necessarily know how necessary that is if you move to IPv6, or how subnetting works with IPv6, if it removes some of the headache or if it makes it worse. Maybe that's something we'll explore in future videos. But anyway, this would be 3. So then we're looking at here, 0, 0, 0. Yes. Okay.
4 from 93? Yes, we can, and we're left with 28. So write a 1 under 64. Next, can we subtract 32 from 28? Well, we can, but we'd end up with a negative number. So for our purposes, no, we can't. So write a 0 under 32.
I haven't taken the exam
Next,
yet.
16 is smaller than 28, so let's subtract 16 from 28. We are left with 12, and also write
God, dude, why do I suck at doing this backwards? How did I get 35? Oh, because I did it backwards. I did two. Why is this 256? Buddy. Buddy.
I am going to take it again, but I am going for the CCNP instead.
Yeah, I'll probably try to get that one after the CCNA. I have a few friends who've gotten the CCNP, but isn't the CCNP also being discontinued? Not devaluing your credential, but I thought I read something that the CCNP.
Studying CCNA/CCNP content.
Is the CCNP cert getting discontinued? No, the CCNP is not getting discontinued. It remains a highly... So there's one that they're discontinuing.
I think you are talking about the consolidation.
Yes. Yes, that is the one I'm talking about. Yes.
a 1 under 16.
Well, good luck,
Next
man.
is 8, and it's smaller than 12, so let's subtract 8 from 12, and write a 1 under 8. Next, subtract 4 from 4, and write a 1 under 4. We're left with 0, so we can't subtract any further.
We're gonna ignore.
That means we
this
can just write
mess
0
that I did.
under 2 and 1. So, there's our answer. Decimal 221 is equivalent to binary 1101
Hey, man, I'm rooting for you.
1100. Let's do another example. Let's convert decimal 127 to binary. Try to figure it out yourself first.
Okay.
Pause the video to find the answer.
Okay, I know last time I said that this was easy. However, this one's easy. It's just gonna be 100000001.
We can't subtract 164 from 127, which leaves 63, and I'll write a...
Why? Why can't we? We can't. The number
1 under 64.
The number has to go underneath. That was my problem. Okay, so what I was doing is that I would be like, oh, it's 100, it's 127, right? Okay, let's put it into whatever. So then I was just making it proper, which is 128, 127, which equals 1. However, that's not how this works. I need to know if this can go into that. If it can't go into that because there's not enough, then it doesn't work. So it's actually flipped. 127 subtract 128. And that would be -1. We can't have negatives. So then this is just 0. Okay. You know, funny story, this used to happen to me when I would play Yu-Gi-Oh! Like way back in the day. I would always...
Jeremy, IT videos do have errors in them.
Okay, I haven't seen any of the errors yet. But yeah, thank you for the update.
Then subtract 32 from 63, and write a 1 under 32, and we're left with 31. Next, subtract 16 from 31. 15 remains, and write a 1 under 16. Subtract 8 from 15.
Okay, so then it just becomes a matter of adding up the numbers. So I shouldn't think about it as doing it backwards because that like really fucks up my brain. I should think of it as just adding the numbers with the lowest denominator. So like this is lower than this number, so I can't use that to add. So 64 plus 32, that would be, I think that's 96. Yeah, 96 plus this.
I bought a CBT Nugget subscription, so I am using that.
Nice. Okay, 26. Yes, and then you keep adding. What I would do if I was doing this is that I would just add these together until I got this number. I wouldn't do the subtraction because we've just demonstrated that I suck at subtraction.
And write a 1 under 8. You're left with 7, so subtract 4 from 7. you get 3 and write a 1 under 4. Subtract 2 from 3 and write a 1 under 2. Finally, subtract 1 from 1 and you're left with 0. There's our answer. Decimal 127 in binary is 01111111. Let's do one more example of decimal to binary conversion.
This one we're going to do it.
Again, try to find the answer yourself. Write down the numbers and convert decimal 207 to binary. Pause the video to think about your answer.
Okay. So 156, right? That's the magic number? 128. Why did I say 156? I don't know. So it's 128. We're not leaving it up to chance this time, boys. Okay. 128 plus 64. And I'm going to go on a limb here and say that we're going to need 32 as well. So let's add those together. So 8 and 2 is 10. That's 14. Carry the 1. That's 2 and 3 is 5. That's 6. 6 and 6 is 12. Carry the 1. Which is over here. Okay, so we don't need the 32. We just need the 128. Okay. So 16 then. So 128 plus 64, that's 12. Carry the 1, that's 6, 7, 8, 9. That 196. 196 plus 16. 196. I think it's 16. Alright. I kind of eyeballed that a little bit, not gonna lie.
207 to binary. Pause the video to think about your answer. First, write out the values for each bit of the binary octet. Subtract 128 from 207 and write a 1 under 128. Subtract 64 from 79
version because
and write a 1 under 64. We can't subtract 32 from 15, so write a 0 under 32. You can't subtract 16 from 15 either, so write a 0 under 16.
Which means that's going to be 8, 4,
Subtract
2, 1.
8 from 15 and write a 1 under 8. Subtract 4 from 7 and write a 1 under 4. Subtract 2 from 3 and write a 1 under 2.
That's what I get for eyeballing shit.
And finally, subtract 1 from 1 and you get 0. There's the answer. Decimal 207 is equivalent to 11001111 in binary.
Well, I just need to memorize, basic stuff. Like, if I remember that 128 plus 64 was, see, I already forgot it. 128 plus 64. 192. So if I can remember things like that, like basic ones, like that's always going to be 192, then I don't have to do the math every single time. I can just kind of group them. I can kind of group them together. Like these of the bottom half are pretty easy because that's 3, 4, that's 7. So 7 plus that's 15. So all of these added up together is 15. Well, I actually used to be pretty good at it, but it's one of those things that if you don't use it, you lose it. You know what I mean? And it's true. The older you get, like, I mean, I'm not that old, but I can definitely tell that I'm using more brain power than I usually do.
Before moving on, you probably figured this out by yourself already, but the range of possible numbers that can be represented with 8 binary bits ranges from 0, if all bits are 0, to 255, if all bits are 1, because 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 equals 255. So, an IPv4 address is really a series of 32 bits. It is split up into 4 octets, and then written in dotted decimal format to make it simpler for us humans to read and understand.
God.
However, you may remember there was this /24 that I said was used to identify which part of the IP address represents the network and which represents the end host. Since an IP address is 32 bits, can you guess what this /24 means?
It's a subnet.
It means that the first 24 bits of this IP address represent the network portion of the address, and the remaining 8 represent the end host.
Wow, that was explained so elegantly. The first 24 bits, because
Crunching numbers on Excel sheets or calculator.
yeah, it's one of the things why, like, I mean, I have like a little AI thing that'll read to me when I.
How it's done in the corporate portal.
Yeah, it really. You're right. Whoa, what's up, man? But it's also the same thing. Like, I don't use. Like I have a little AI tool that. No stream on Tyler Lemon. Oh, crap. Thank you so much for telling me. Okay. No, the stream is there. It's just private because I'm a dummy. Thank you for letting me know, man. Yeah, streaming to no one, buddy. Oh my gosh. What a bonehead move. Rookie mistake. Normally I check it. But anyway, to go back to the calculator thing,
Mayo use RAM in multi-platform.
yeah, I stream multi-platform. I do it on this channel to the Tyler Lemon channel. The Paradiddle Pete channel was originally music and drums, and then it became gaming, and then it became networking. But I didn't want it to become networking because I didn't want my name to be Paradiddle Pete in the professional world. So then I created a professional YouTube channel, and I'm trying to like divert traffic to go to Tyler Lemon, which is like there's a bunch of like network videos and stuff on there. So anyway, let's continue on.
So the first 24 bits is equal to the first 3 octets, because 8 plus 8 plus 8 equals 24. So 192.168.1 is the network portion of the address, and 254 is the host portion. Here's a quick look back at our small network. The IP address of PC1, PC2, and R1's G00 interface are 192.168.1.1/24, 192.168.1.2/24, and 192.168.1.2.
Okay, so the 24, he explained this really elegantly, is that it's the first 24 bits is the thing. So that what he did is he to get this side R, which I don't even know if I'm saying that acronym correctly, because I've never heard anyone say it. I've only ever read it. I don't. It could be sitter, but anyway.
At sanjaykumar.b8139 note, but I do hold the networking position. I failed on subnetting/IPv6 routing.
So we take the binary here and add those numbers up, and those are the bits. So there are 24 bits that are created into these octets. Interesting. Hey man, but you're gonna pass the subnetting IPv6 next.
54/24.
Next time. I can
Notice
tell.
that the network portion of each IP address is the same, because they are all part of the same local network. Only the host portion is different.
So that means the lower this number, the lower this number, the more addresses we have. Yeah.
Likewise, the IP addresses of PC3, PC4, and R1's G01 interface are 192.168.2.1/24, 192.168.2.2/24, and 192.168.2.254/24. Only the host portion of the address is different because they are on the same local area network. Let's follow the same process as before with another IP address. If you want some extra practice, try to convert these 32 binary bits into an IPv4 address. Pause the video if you want to try and find the answer on your own.
Okay, so they want us to he wants us to turn this into a thing. And then we're gonna do the thing. All right, here we go. 1 0 0 1 1 0 1 0 0 1 0 0. Oh my goodness. Yeah, probably. Honestly, like subnetting's just it's just a skill. Like once you practice and like you have it down, you have it down. You know what I'm saying? 1 2 3 4 5 6 7 8. Man, this is hard to read. I'm not gonna lie. 1 2 3 4 5 6 7 8. Right? Because it's an octet. Yeah. Oh my god, I lost my place again. Okay, oh, hold on. This is what we're gonna do. 1 2 3 4 5 6 7 0 1 0 0 0 1 0 0 1 1 1 1 1 1 1 2 3 4 5 6 7. We need one more.
I have scheduled my exam this month and I got the safeguard luckily.
Good for you, ma'am. Hope everything goes well for you. Really do. 0 1 1 0.
BAB 139. Do you have a CCNA or are in the process of getting one?
1 1.
But yet to practice subnetting.
1. Is that 8? 1 2 3 4 5 6 7. Damn it! And I lost my place. 1 2 3 4 5 6 7 8. So it's one more 1.
Practice subnetting this week.
0 0. How many zeros? 1 2 3 4 5. 3 4 5 6 7 8. 6 7. Okay, here we go. All right. So then now we should be able to figure all this out. Okay. I need my drawing tablet. I want my drawing tablet so bad. So we're gonna, because it's gonna be so much easier.
BAB 139. I would practice that a lot. I had a question asked me to create a subnet and build the routing table out.
Dang. See, those are some of those questions that I feel like they're hard because it's a hard skill, but it's an easy one because you know that it's going to be on the test. You know what I'm saying? Window capture. We're going to capture paint. It didn't capture paint.
Oh, this is a lab simulation. Will do my best.
Okay. So we have 150. What is it? 156? Is that what it is? Always forget. No, it's not 156. It's 120.
To all the commands in the iOS terminal. Any other ways to practice subnetting or those websites are enough?
The packet tracers really help me. Like I do those packet tracers like all the time. Not just Jeremy's packet tracers, but you can go on to Cisco's website and you can download the packet tracers. Those are really good. Let's see here. 120. Damn it.
Boson worked really well, but it does cost money.
Address. Only the /20. Otherwise, the are all 20 small network. 8 represent the end. Guess what? The 4 octet plus 4 plus 2 plus 1.
128. I don't know why I keep forgetting that. It's 64 plus 64. Okay. 128, 64, 32. We're going to do this one, boys. I'm determined. 16, 8, 4, 2, 1. So that's going to be, I'm going to use my calculator though. just because I don't feel like writing it with my mouse. Yeah. So 128 plus 16 plus 8 plus 2. 154. Dot. Okay. Wait, do I have more than 1, 2, 3, 4, 5, 6, 7, 8? No, I don't. Okay, so the next one is 64 plus 2 plus 4 plus 8. 74. Sorry, 78. Dot. Dot. Okay, 64 plus 32 plus 0 plus 8 plus 4 plus 2 plus 1. 111. And then this one should just be 32. And that should be it. Final answer. Let's find out if we're right. 152, 78, 11, 111, 32.
Convert these 32 bits into dotted decimal. Pause the video now if you want to try. Or octets, like this. And then convert the octets into
Damn it, I wrote those. Yeah, I've noticed that like when I took my Network Plus, my A Plus, I hadn't taken an exam like that in probably 8 years. And I went in to go do it and they told me, yeah, and they're like, you can't dump, you can't write everything down that you possibly know, which is so strange. Because when I was going through school, I guess, I mean, that makes sense. But when I was in school, that was a test taking strategy, was to get a piece of paper and to dump out as much knowledge as you knew on the piece of paper that you would write out on the day of the exam. Like that was the meta. Like when I was in junior high and high school, that is what you did. That's what teachers taught. And then when I got there and they're like, yeah, you can't do that. I'm like, what? What do you mean I can't do that? Like, it's just, I don't know. It's strange to me. I guess I kind of understand it, but it is strange. I definitely wrote all these numbers down wrong.
Dotted decimal, like this.
Because why did I put a 1? Damn. Well, that's also Reddit though. Like, I don't know how much I trust Reddit nowadays. If this would have been like 2013, I would have been like, oh yeah. But I don't know. In 2026, I don't know how much I trust what goes on Reddit. But I added a decimal.
This time it's /8. So which part of the address is the network portion, and which is the host portion? Since the first 8 bits are the network portion, that means that the first octet is the network portion, and the last 3 octets are the host portion. So, 12 is the network.
Just so that you guys know, whoever's watching, he just made this 8 up. He didn't pull that 8 out of anywhere. He just changed it from 24 to show you that it's just the first octet.
Portion, and 128.251.23 is the host portion. Now, IPv4 addresses are split up into 5 different classes. The class of an IPv4 address is determined by the first octet of the address. The first is class A, which has a first octet beginning with 0. If the first octet begins with 0, that means that the numeric range of the first octet is from 0 to 127, because 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 gives a maximum of 127. The second class is class B, which has a first octet beginning with 10, and therefore a numeric range of 128 to 191. The third class is class C, which has a first octet beginning with 110, and therefore the numeric range for the first octet is 192 to 223. Class D has a first octet beginning with 1110, and the numeric range of the first octet is 224 to 239. Finally, Class E has a first octet beginning with 1111, and therefore the numeric range for the first octet is 240 to 255. However, the classes of address we'll be focusing on are A, B, and C.
Wow, that's expensive. $375. It's a big deal.
Addresses in Class D are reserved for multicast addresses. Multicast is another type of address separate from the unicast and broadcast addresses we talked about in previous videos. We will talk about them, but that will be later in the course. Class E addresses are reserved for experimental uses, and we won't talk about them in this course. Now, one more thing about the Class A range. The end of the Class A range is usually considered to be 126, not 127. Why is that? Let's take a look. The 127 range is reserved for loopback addresses. The range is anything with a first octet of 127, so 127.0.0.0 to 127.255.255.255. These addresses are used to test the network stack of the local device. If a device sends any network traffic to an address in this range, it is simply processed.
You guys got me curious. Okay, let's see here. What is the failure rate for the CCNA? Yeah, I did get better at subnetting because of the Network Plus, because it asked for that. And that's how I kind of understand it. That I even made a like a beginner guides video on the Tyler Lamond channel, and I'm working on a much bigger video that kind of goes in depth with the math and the strategies that I use. Okay, so Cisco does not publicly disclose official failure or pass rates for the CCNA. Okay, that sounds like fun. Let's do that. However, industry estimates suggest that the first-time failure rate is 50%, with some source estimating as high as 80% to 95%. The overall pass rate across multiple attempts is estimated to be roughly 80%. Wow. So he's not too far off. That's crazy. That's insane. No, I'm not going to do the subnetting stuff right now because I'm almost done with this video. I want to finish this to keep track on my my study schedule.
Processed back up the TCP IP stack as if it were traffic received from another device.
But I will plan that for next stream for Thursday. Does that sound good?
In this image, I pinged 127.0.0.1 on my Windows PC, and you can see the responses. My PC is responding to its own pings. In this image, I sent a ping to a random IP address in the 127 range, 127.23.68.241, and again my PC responds back to its own ping. Notice the round trip times, all 0 milliseconds. That's because the traffic isn't going anywhere. My PC is just sending and receiving these pings to and from itself. So, here's the chart again with just classes A, B, and C. I've also added one more column, the prefix length, which is the /8, /16, and /24, which is used to identify the length of the network portion of the address. Class A addresses use a /8 prefix, Class B addresses use a /16 prefix, and Class C addresses use a /24 prefix. Actually, if you look back at these three addresses we used in our examples, you can see they are Class A, Class B, and Class C addresses, and their prefix lengths match the table. /8 for Class A, /16 for Class B, and /24 for Class C. In Class A, there are fewer possible network addresses. However, because the network portion is very long, there can be many hosts on each network. Class C is the opposite. There are many possible networks, but because the host portion is smaller, there are fewer hosts on each network. Let's take a look at the numbers. So, this is another chart I've taken off of Wikipedia. The leading bits column refers to the first bits of the first octet, which I displayed in my previous table. The size of network number bit field, displays the number of bits in the network portion of the IP address, which, as I mentioned, is 8 for class A, 16 for class B, and 24 for class C. Size of rest bit field indicates the remaining number of bits in the address, which is the host portion of the address. 24 bits for class A, 16 for class B, and 8 for class C. Now, this part here displays the number of possible networks in each class. As I said, class A has fewer potential networks, but more hosts in each network. Class C is the opposite, and class B is in between. Class A has 128 possible networks. Class B has about 16,000 networks.
That's crazy.
And Class C has about 2 million networks. Class A allows about 16.7 million hosts in each network. Class B allows about 65.
It took me so long to understand the difference between, like, the concept of this is the network. I usually study until I finish the video, and then I've done the Anki cards and maybe a packet tracer if there is one for the thing. Currently, it usually is about for like an hour, 2 hours. But as I keep going and doing more and more, I'm going to be reviewing more and more. Like once we start getting more into subnetting, I'm probably going to review subnetting every single stream, regardless of whatever it is we go over. So it'll probably branch out into being 3-4 hours eventually. Yeah. So I actually have I'll show you my study schedule if I can, if I can find it. Let's see here, CCNA. But anyway, I built a study schedule based off of Jeremy's IT labs, off of his videos, and I'm doing it twice a week on Tuesdays and Thursdays at 8 a.m. And eventually I'll probably end up streaming from 8 a.m. till noon. But right now I'm just kind of going until I'm done with the stuff. I'm just kind of adding it on, scaffolding it kind of thing. I don't know what happened to my thing. If I find it, I'll show it to you.
5,000 hosts in each network, and Class C allows 256 hosts in each network. However, because the first address in each network is the network address, it can't be assigned to hosts.
I think I feel pretty good about it.
Also, the last address of the network is the broadcast address, the layer 3 address used when you want to send traffic to all hosts. And it also can't be assigned to hosts. So really, the host count is 2 less. For example, 254 in Class C. Now I want to briefly talk about another way of writing these prefix lengths. Using a slash, followed by the length of the prefix, is a newer and easier way of writing the prefix length. On Juniper network devices, for example, you write prefix lengths using this slash notation. However, Cisco devices still use an older, slightly more complicated way of writing the prefix length. That is using a dotted decimal net mask. A net mask is written in dotted decimal like an IP address, where the network portion is all ones and the host portion is all zeros. For example, the network mask of a Class A address is 255.0.0.0. That's the dotted decimal version of 11111111, followed by 24 zeros. So what do you think the net mask of a Class B address is? It's 255.255.0.0, which is 2 octets of ones, followed by 2 octets of zeros, written in dotted decimal. Finally, what do you think the net mask of a Class C address is? It's 255.255.255.0, which is 3 octets of ones, followed by 1 octet of zeros, again written in dotted decimal notation. So these prefix lengths and these net masks are the same things, just written in different ways.
Okay.
Before moving on to the quiz for today's video, I want to explain 2 more types of IP addresses, which I briefly mentioned before, the network and broadcast addresses. If the host portion of an IP address is all zeros, it means it is the network address, the identifier of the network itself. In our diagram here, you can see 192.168.1.0/24. We know that /24 means the first 3 octets are the network portion, and the last octet is the host portion. Since the host portion is 0, it means the last octet, the host portion, is all zeros. Therefore, this address, 192.168.1.0/24, is the network address. Keep in mind, the network address cannot be assigned to a host. The network address is the first address of the network, but the first usable address is one above the network address. In this case, it's 192.168.1.1, which is assigned to PC1.
Man, when I was doing my Network Plus, that was not explained well to me. And there's a stream somewhere of me crashing out hard trying to figure that shit out. So, This is the network. That's the name of it. And since it's the name of the network, it can't be used. Anything inside of it is there. So then point 1 is the first usable address of this network.
So the network address is the first address, with a host portion of all zeros. However, the last address in a network, with a host portion of all ones, is the broadcast address for the network. Like the network address, the broadcast address cannot be assigned to a host. So, although it's the last address in the network, the last usable address is actually one under the broadcast address. In this case, that's 192.168.1.254,
Yes, and the
address
broadcast
assigned
is the
to
same
R1's
exact way.
G00 interface. So, the broadcast address is the layer 3 address used to send a packet to all hosts on the local network. If a packet is sent with this destination IP address, what do you think will be the destination MAC address of the frame it is encapsulated in? Think
Oh, this is a broadcast. So it's going to be a flood?
about the Ethernet LAN switching
Fs.
videos.
It's going to be Fs.
It will be all Fs, the broadcast MAC
Yes.
address. If PC1, for example, sent a ping to 192.168.1.255, it would be received by PC2 and R1's G00 interface. Once again, I think we've covered a lot of ground in this video.
Thanks.
Let's list what we covered before moving on to today's quiz. First, I talked about dotted decimal and binary.
Yeah, we went over a lot of stuff
Binary is
today.
how computers think, but 32-bit IPv4 addresses are difficult to remember for us humans. So we convert IPv4 addresses to dotted decimal form to make them easier to read and remember. You learned that IPv4 addresses consist of a network portion and a host portion. Hosts on the same network will have the same
Well,
network
isn't
portion.
a broadcast and a flood the same thing? I'm pretty sure they are. Because a broadcast goes out to everyone except for whoever sent it, and when you flood all the channels, it does the same exact thing.
But a unique host portion of their IP addresses. You learned about the IPv4 address classes. We looked at the different ways of indicating the length of the network prefix, by writing the prefix length with a slash, or by using a net mask. And finally, you learned about the network address, which has a host portion of all zeros, and is used to identify the network itself, not any particular host on the network. Also the broadcast address, which has a host portion of all ones, which is used to send network traffic to all hosts on the network. So, before moving on to the quiz, I want to remind you to download and use the flashcards for this lesson to help you remember what you've
Yeah,
studied
I
in
got
this
this.
lesson. Now, for
There's
today's
somewhere.
quiz, I'm going to focus exclusively on converting IPv4 addresses between binary and dotted decimal. There will be 10 questions instead of the usual 5, and hopefully, afterward you'll feel confident converting IPv4 addresses between binary
Yeah, there
and
is.
dotted
I got
decimal.
it right here.
Let's get started. Question 1. Convert the following IPv4 address to dotted decimal notation.
Okay, so this is so much easier when there's spaces in between them. So 1, 3, 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 32 is 40. 15 plus 32 is 47. Really? Okay, 47. And then 47 plus 64. 64 plus 47. I gotta say it the correct way and put it in my head. 47. So 64, 47, 4, 7. That's 11. Carry the 1. That 4 becomes a 5. 5 is 11. So 111.
Pause the video to solve the question, then unpause to check the answer. 1.19.
I've got to the hundreds, man. I gotta practice this more. No, because I went to 64. I still didn't get 63 though. Let's try it one more time. 1 plus 2 is 3. 3 plus 4 is 7. 7 plus 8 is 15. 15 plus 16 is 11. 21. That's where I messed up. 21. And then 21 plus 64 is still not 63. 32. Okay, that makes a little bit more sense. This one's easier. That's 1, that's 2, so that'd be 3, 4, 8, 16. So 16 plus 3, 1, 2, 3, it's 19. Okay.
Let's go to question 2. Convert the following IPv4 address to dotted decimal notation. Pause the video to...
Okay, obviously that's 1. We're going to use the calculator instead of using my brain because it has been proven to be wrong. Okay, so you're 128. We're doing the first one right here. 128 plus 64 plus 32 plus 16. 8, 4, no, 2 plus 1. So I did 128 plus 64 plus 32 plus 16 plus 0 because there is no 8 plus 0 because there is no 4. And then plus 2 plus 1 equals 243. Okay. And then this one's easy. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64. 125. Okay. And then this one is 64 plus 32 plus 2. 98. And the other one's 1. So our answer should be 243, 125, 98, 1.
To solve the question, then unpause to check your answer. The answer is 243.127.98.1.
Why is this 127? How did I get that wrong? Oh, damn it. I forgot to add 2. I did 1 plus 4 plus 8 plus 16. I forgot the half note. Okay.
Let's go to question 3. Convert the following IPv4 address to dotted decimal notation. Pause the video to solve the question, and unpause to check your answer.
Okay, here we go. I'm going to add them up going this way, starting here. So we have 1 plus 2 plus 4 plus 8. 1 plus 2 plus 4 plus 8. No 16. There's 32 and 64. 32, 64. So that should be 111. And then we have 2 plus 4, which is 6. Okay. And then we have 1 plus 2, no 4, no 2. 8 plus 16 plus 64. That's 98. And then we have 1. Oh, dang it. What is it? 228? Yeah, 128. I always want to do 2 for some reason. 128 plus 64 plus 1 plus 2 plus 4. So we should be looking at, so long as I didn't screw up again, 111, 6, 90. There's no way that's 98. 89. 1, 2, 4, 8, 16, 32, 64. Yeah, 89 and then 199.
The answer is 111.6.89.199.
Okay, we're
Let's
doing
go
better.
to question 4. Convert the following IPv4 address to dotted decimal notation. Pause the video to solve the question, and unpause to check your answer.
Okay, we're gonna try to do it in our heads again. I know that hasn't really worked out in the past, but I have a feeling it's gonna go different this time. So 1, 2 is 3. So these first 4 are always going to be 1, 3, 7. It's always gonna be 15. Because 1, 2, 4, 8, 16. Yeah. So this is 15 plus 128 and hold on. I'm learning. What is 128 plus 64? 128 plus 64 is always 92. So these two are always going to be 92. This is always going to be 15. So 192 plus 15 should be 207. Okay. So then this is 198 plus 2 and 4, which is 6. So 198 plus 6, that'd be 199. Two 204. Is that correct? 15 added to 32. That's 7. That's 47. Yes. That's 4 and 8 is 12. 12 plus 64 is 72.
The answer is 207.198.47.76. Let's go to question 5.
Lost one.
Convert the following IPv4 address to dotted decimal notation.
Okay. Wow, man, that used a lot of brain power. I'm not going to lie. All right, we're going to use the calculator on this one. But I'm starting to understand. So this is going to be 4. And then another good one to memorize is 64 and 32 is always going to be 96. So 96 plus 4 is 100. And what did I say that those were always going to be? $192. Oh, that's right, because of Class C. So... Well, I do have... That's why I pulled up that paint. And I have a drawing tablet to help me write or whatever. But for whatever reason, my drawing tablet is linked to only this monitor. So... And then I tried to get OBS to, like, pick up the window. And it wasn't able to pick up the window. So I don't really know what was going on with that. Anyway... Yeah, just go to Wacom. They're not too expensive. I think this one was like $50 or something, which is kind of expensive, but it's also something that I'm probably never going to need to buy again. So that's how I rationalized it. Let's do this one. Okay. So we have, what was that, 98? 64 plus 32 is 96 plus... Yeah, you probably could. You probably could use it. Yeah. I've never used the tablet, but I can only I can't imagine why that wouldn't work. 4, so that should be 100. Okay, 64 plus 32 plus 4. And then that is 192 plus 2, 4, 8, 9, 201. One of the ways I'm getting better with it is that instead of typing them all out, I'm only like I added that in my head and I added this in my head and then I added that on the calculator. So this is going to be 1, that's 32, that's 33. And then this guy is going to be 1, 9. Ooh, man. So what is 16 plus 32 plus 64 plus 128? 240. So the first half of the octet is always going to be 15, and the second half is always going to be 240, and that makes sense because they add together to make 255. So that means that this is 241. No. This is 253.
Pause the video to solve the question, and unpause to check your answer. The answer is 100.201.33.253.
Yes.
Let's go to question 6.
Nailed it.
Convert the following IPv4 address to binary notation. 88.46.90.91. Pause the video.
Okay, we should be able to do this. I'm gonna try to get the paint again. Okay, and then let's see if it'll work this go around. Window capture. No, I don't know what it is. It like refuses to pick up the paint. Interesting. Whatever. Okay, I'm gonna write it out real quick. So we have 88. I know you guys can't see this, and I apologize. 46, 90, 91. And then it's gonna be not 2. 128, 64, 32, 16, 8, 4, 2, 1. Okay, that should be enough to get us going. So 88. So all we got to do is we got to figure out the combination that adds these together. So it's got to be 64. 64 plus 32 is 96. So that can't be it. So 64 plus 16 is 80. So that works. So we have here, and then we have here, but that only gets us to 80. So we need one more. Everything else is going to be zeros. So this one is going to be 0, 1, 0, 1, 1, 0, 0, 0. Whoops. Ooh, what is happening? What is happening? I hit the stupid buttons on my stupid thing. Okay. Now 46 should be the next one. So obviously we need a 32. And then 32 plus 16, 2, that's 8. And then that's 48, so that's not going to be it. So we need an 8. So 32 plus 8 is 40, because 2 plus 8 is 10. So we're at 40, and now we need 6, which we have right here. Okay. 0, 0, 1, 0, 1, 1, 1, 0. Okay, we're doing pretty good so far. Now we need the 90. The 90 is going to be, it's going to be 64. But I don't think it'd be 32, because that would be 96, right? Yeah, that'd be 96. So then we need it to be 16 and 8, because that would be 10. That would be 70. 78. Wait, what is 64 plus 15? Is it all of these? 15, that'd be 16. That'd be 11. That'd be 30. No. Hold on. I tried to skip steps, and then it bit me in the ass. 64 plus 16 is 70. 70 plus 8 is 78. 78 plus 4 is 82. Did I screw up? Okay, hold on. 64 plus 32. Yeah, it's 96, so it can't be that. So it's got to be 16, which is 80. That's where I messed up. Because 6 plus 4 is 10. So 7 plus 1 plus 1, because you carry the 1, that would be 80. Plus 8, which would be 88. Plus 4, which would be 92. But that breaks it. We don't want that, so it would have to be 2. So it'd be here. Okay, I feel like I'm getting faster. 0, 1, 0, 1, 1, 0, 1, 0. Okay. And the last one is 91, so we're literally just going to add another one. 0, 1. Oh my god, my mouse sucks ass. 1, 1, 0, 1, 1. Okay, that should be it.
Video to solve the question, and unpause to check your answer.
See if I'm right.
And here's the answer. Let's go to question 7.
No, hold on. I need to check that. 0, 1, 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1. You nailed it. Yes.
Convert the following IPv4 address to binary notation. 221.234.246.163.
Okay. I'm gonna do the same thing. Dang, dude, I really wish that would work. I really wish that would work. You know what I could do, though? Yeah, I don't know why it's not working. Yep, still nothing. Whatever. Okay, let me write this down really fast, just like I did last time. I'll erase it real quick, though. Oh, shit. I don't want to erase that. I just want to erase this. Okay, let's see here. Two 221, 234, 246, 136. Okay, let's do this one again, boys. Here we go. So it's got to be one. It has to be these two for sure. 128 plus 64 is 192. Plus 32 breaks it. That makes it 208 plus 8, 16. So that's what it is. I wonder if I could have... No, I only have displays. Ooh. No, wouldn't be worth. Let me write this down. One one zero one 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 zero one. So this shouldn't be too difficult because I just need to add in like, because it's 34, right? So then add 32. No. No, it's going to be a different combination. 64. Dang it. 128 plus 64 is 192. We already know that. Plus 32 is 124. Plus 16 breaks it. So then it's got to be plus 8. And then plus 2. So we have... We have 28, 64, 32, 8, and 2. Fantastic. 1, 1, 1, 0, 1, 0, 1. So then... that means this next one, this is it, because this breaks it, or this broke this one, turned it to 240. So now we're at 240 because that's 192. So this makes, oh, we already know that the first nibble or the second nibble is 140. So then now we need 146, which is just gonna be these. So 1 1 1 1 1 1 2 3 4 5 7 8. Okay, good. Now this one's gonna be a little bit different. We're definitely gonna need this one, but we don't need this one because 128 plus 64 is 192. So that's gonna break it. We don't want that. So that means 128 plus 32 is gonna be 128 plus 32, 160. Okay. And that we need 3, so then it's gonna be here. So we're gonna have 1 0 1 0 0 1 0 1 0 0. We need one more 0. All right.
Pause the video to solve the question, and unpause to check your answer. And here's the answer.
Okay, check it real quick. Let's see here. 1 0 1 1 0 1 1 1 0 1 1 1 1 0 1 0 1. Damn it, I forgot a 0. 1 1 1. Ooh, I got this one wrong. 1 1 1 1. I misplaced a 0. Okay. Okay. Just keep going.
Let's go to question 8. Convert the following IPv4 address to binary notation. 3.41.143.222. Pause the video to solve the question.
Okay, we're going to try to do this one in our heads, boys. So we have 3.41.143.222. Try to give myself a little bit more space here. Okay, so obviously this one is 0 0 0. Hold on. That's 32, 16, 8, 4, 2, 1. Okay. So then 41's got to be, these have to be 0, or these have to be 1s. Because 15 plus 32. 32. Oh, no, there can't be a 16. So 32, because 32 plus 16 is 48. That breaks it. But 32 plus 8 is 40. So it's going to be 0 0 1 0 1 0 1 1. Okay, and then 143. It's got to be 128. It can't be this because that would be 192. So then it's got to be 33 or 32. That would make this, no, that still breaks it because 2 plus 8 is 10. Carry the 1, 5, that's 60. No, it's still not that. 16 maybe. Because 6 plus 8, ooh, that's a weird number. It's not weird, but it doesn't follow certain rules that I haven't placed in my brain. Oh, but I can make it by doing that. Okay, I'm sorry. I'm talking nonsense because half my thoughts are staying in my head. I apologize. I'm going to subtract 1 of that, make that 5 to make this 9. That'll make it 14. That'd be 4, carry the 1. That's 34. So 134. Okay. Can I check that real quick? 128 plus 16. What? Oh, carry the 1, because 8 plus 6 is 14. So that's 4. Carry the 1. 2 plus 1 is 3. Plus 1 is 144. So this breaks it. That, man, I would have got that wrong. If that was a gun, I would have died. Okay. So right now, so then it's got to be 128 plus 8 plus 4. Can I make this an easier number for me? 12. Okay, yeah, let's make it 12. 12 added to that, so that would be 2. That would be 10. Carry the 1. 1, 2. It's 12. So that would be 40. So this is what it is. 1 0 0 0 1 1 1 1. Okay, I think I did that correctly. So then the 222 has to be these two because that equals 198 or 192. Okay, double check that real quick. I hate when my... Yeah, 192. Okay. So that equals 192. And we're going to need to hit to 122. So so a lot of people think math is all about math. Math really has very little math in it. It's all patterns. Like if you can just memorize like how some of the patterns work, then like life gets way easier. And then you just have to have the mental capacity to keep track of all the numbers, which is easy. Like if you don't have that right now, you can easily get that. Just start reading some books and your mental capacity will like grow like so much stronger. So 192, that'd be 2, that's 4. 9 is 12, that's 2. 120, 121? Is that correct? 124. Dang it, I went backwards. I hate when I do that. Okay. So that means we can't do this. That means we need to have at least 16 and 8. Because 16 and 8 is a fourth away from 32. Which honestly, if it's a fourth away, is it going to be this? 16 plus 8 plus 4? So close. There we go. All right, let's check it.
To check your answer. And here's the answer.
Okay. 0 0 0 1. Okay. 0 0 1 0 1. Ah, I forgot a fucking 0 again. 1 0 0 0 1 1 1 1 1 1 0 1 1 1 1 0. Okay, cool.
Let's go to question 9. Convert the following IPv4 address to binary notation: 10.200.231.91. Pause the video to solve the question, and unpause to check your answer.
All right, let's write this down real quick. Oh, what is it? 10 plus 200. 231. 91. All right. So 10, obviously, it's got to be these. No, that broke it. It's got to be these. So let's see here. 0 0 0 0 1 0 1 0. Okay, and then we have 200. So that 200 is going to be, this is 192. So we really just need 6. See, and that's like, we got to be able to see those patterns. 1 1 0 0 0 1 1 0. Okay, and then we need 132. Well, we just did this, and if I remember correctly, these 3 is 140. So it would break it. Let's test it. No, it's 208. No, it's not. That's a lie. It's 224. So these 3 is 224. So we're just 6 7. 6 7. We are 7 away. So really it should just be these, right? Let's find out. Plus 4 plus 2 plus 1. That is correct. I'm getting faster. 1 1 1 0 0 1 1 1. Okay. Next chunk, 91. So we're definitely 64. Oh, but that would make it 92, doesn't it? 32 plus 64, 96. And then 6 and 8 is a fourth away from 32. Because that'd be 4, 8, 12, 16, 24. That'd be 80, 88, right? 64 plus 16 plus 8. 73. Damn. How'd I get that so far off? Plus 4 plus 2 plus 1. No, something's not right. 64 plus 32 is 96, so it breaks it. So it's got to be 16 plus 8 plus 4. There it is. So we're at 0 1 0 1 1 0 1 1.
And here is the answer.
0 0 0 0 1 0 1 0 1. Yes. Damn, I got this one wrong. Okay. All right. I'm still averaging out a
Let's go to question 10.
thing.
Convert the following IPv4 address to binary notation. 248.87.255.152. Pause the video to solve the question, and unpause to check your answer.
All right. Let's see here. It's the last one, boys. 248. 7 87 255 152. Okay. We're going to try to do this one since it's the last one. We're going to try to do it with like our brains, okay? So 248 that we know that the nibble over here is 1 1 1 1. We know that's 240. So it's got to be this one. So, and because I wrote that too small, we're going to move this over here. 1 1 1 1 1 0 0 0. 86. Or sorry, 87. 64 and 16. That's 10. 7. That's 80. That's exactly 80. 64 plus 16. Yes. So then 87 would have to be these. 0 1 0 1 0 1 1 1. Don't know what that is that I just moved. Okay. Oh, and then this is if it's 255, then it's all ones. 1 2 3 4 5 6 7 8. 152. That makes 150. Because 5 and 2. This is a 2. 2 and 8 equal 10. Carry the 1. Oh shit. 2 and 8 equal 10. Carry the 1. So that would actually be 160. So it's not this. It's gotta be 16. That's 3. Carry the 1. That's 4. So we're at. This is why I got messed up with 2. With 8 plus 6, which is actually 9 plus 5, which is 14. So 4, carry the 1, 2. So we're at 44. 144. So we're almost there. 144, 45, 46, 47, 48, 49, 50, 51, 52. Okay, let's see if we're right. This is the last one, boys.
And here's the answer. Okay.
No, I need to check it.
And here's the answer.
Correct. 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 Nailed it. First try.
Okay, that's all for the quiz. I hope you feel confident converting IPv4 addresses between binary and dotted decimal notation.
I haven't done that in so long.
As usual, there will be supplementary materials to help you review what you've learned. There will be review flashcards using Anki, which I highly recommend you download and use to review. There will also be a packet tracer practice lab.
Second.
However, it will be after part 2's video, so there won't be a lab for today's video specifically. Good luck with your studies. Thank you for watching.
Dope.
Please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA.
Yeah, if you're not subscribed to Jeremy's IT lab, you definitely should be. Like, they're really, really, really good. They're like super, super good. So yeah, definitely do that. Let's look at these Anki cards. Okay, we're gonna do 6 and 7, no pun intended. Okay, because last time it was here, I had to leave early. We weren't able to do 6. There's only 17 of them, so it shouldn't be too bad.
Good job.
Thanks, man. Oh, hey, I found my study roadmap if you want to look at it. So 6 hours per week, approximately, because it's probably going to be way more than that. It'll probably turn into more like 10 hours a week. 32 sessions, 4 phases, 1 exam. Who is this for? Like, this is what I'm trying to do. Why is this plan exist? What does it work? How is it going to work? And then 2 is the study schedule.
How did you create that?
Oh yeah. I typed it all into Claude to like turn it into like a thing. Like, you think I'm gonna take time out of my day to make a Word document look nice, buddy? Like, this is 2026. Those code munchers can do this. Like, I'm not making a Word document. So yeah. But I follow it pretty religiously, honestly. We got phase 1, which is weeks 1 through 4, and so on and so forth. And what I really like about it is that it got all of the playlists in there. So I can do it in here. I even linked it to my Google Calendar, so like it, the alarm goes off and wakes me up even though like I don't want to wake up, kind of thing. The resources and the things that I need. Here's some other links, and then here's the master schedule as well of everything that I'm gonna do.
I finished the CCNA course from CBT Nuggets. I did Jeremy IT Labs and his Mega Lab at the end helped me pass the test.
Nice. Way to go, dude. Way to go. Good for you. Hey, W's in the chat. W's in the chat for AMW Films. Good for you, dude. So phase 2, switching and routing, things like that. And it's kind of broken up in terms of like what my CCNA courses were. This is the part that I struggle with. The NATs, the VLANs, the IPsec, like these are the things that I struggle with. So this stuff right here is just a review. Like it's kind of easy. I understand what's going on. This stuff is actually what I really like doing. I think it's really, really interesting. And then this is the stuff that I struggle with. So I'm a person who likes to complete things, and I'm not someone who likes to jump around. So I also understand, because I was a teacher, so I also understand that if this is where I'm struggling, then the problem is probably from somewhere in here. It's probably not actually in here. There might be something, probably is something that's in here that I think I understand that I actually don't understand. And if I just go back and watch the entire series, then I'll be fine. I'll catch it. But anyway, let's do some Anki flashcards. What is... I'm not familiar with CBT Nugget. Oh, I do know this. I've never done anything with it. Okay, that's reasonable. I mean, I don't want to spend that, but I mean, it's reasonable. Like, I see, like, All right, what is the size of the Ethernet header plus trailer? No preamble. 48? 18. Oh, because no preamble. Yeah, I'm gonna have to go back and relook at some of this stuff. Okay. Yeah, we're gonna do it again. What is the minimum size of the Ethernet frame?
I like them because they make everything bite-sized so you can understand Jeremy better. Jeremy is a CCNA leaning CCNP style of teaching.
Interesting. Hey, you know what?
It's $60 a month.
Yeah, no, it looked like a pretty reasonable deal. Audio output. I just realized that the TTS wasn't working. Audio output capture. Chat. Okay, I hate when things don't work. Okay, I'll worry about it later then. Yeah, like that didn't work. Window didn't capture it. None of this stuff's work. I don't know. I'll worry about it later. Okay, what is the minimum size of an Ethernet frame? 18, right? 64. Man, I'm getting railed. What is the size of the Ethernet?
And CBT Nuggets labs come ready-made as well, so you work on labs that feel like real-life issues.
That's awesome. That's what I really want. And honestly, the CCNA 2 test that's going to come out in February is going to be mainly about that. Actually, hold on. I think I figured it out. We're going to go here. Chat 1. Why does that work? No, nothing works. Okay, whatever. I'm not. I tried. I'll try it. I'll figure it out later. I just hate when I'm trying to figure something out and I can't figure it out and then I have to like stop because it's not the time, you know? Priorities. What is the size of the Ethernet header plus the trailer? No, it's 18. Yep. What is the minimum size of the Ethernet frame? Wasn't it 48? 64. What is the minimum size of the Ethernet payload? The Ethernet payload.
I feel like Jeremy IT drove too much information on you and not the right type of information.
For the test or just in general? When you say that you feel like Jeremy drove too much information, do you think that's because of the test or just because of like the teaching style? What protocol is used? I don't know what I just did. I don't know. I need to focus on things that are more important. What protocol is used to discover the layer 2 address of another? What protocol is used to discover the layer 2 address of another device? What protocol is used? I have no idea. Oh, stupid. I did know that. Okay. Of a layer 2 device too. Okay. What is the minimum size of an Ethernet payload? Isn't it? I want to say it's 42, but I don't think it's 42. I think it's like 86. Dang it. Man, I'm getting railed. What two messages are used in ARP? The request and sender. Oh, the reply. ARP request message is blank cast. That is it's a flood. It's a unicast. No, it's a multicast. Broad. Oh, broadcast. Hey, this is our first ad that we've had.
I think it's because of the teaching style.
You just think that it was too much information?
He does, but if you can retain it, you can get a job much easier, as he is giving you a high to low level teaching of infrastructure. Good luck on your studies, you're on the right path.
Interesting. Interesting perspective. Yeah, I would much rather have, like when I'm learning, and you can see this with my AI prompt too, if it'll load. And I've talked about this in past streams, that like my AI prompt is supposed to give me 4 things. It's supposed to give me a simplified answer, so that way I can just understand it immediately. Then an analogy, so that way I can like relate it to something. And then a more in-depth explanation. So like this industry standard, like what is the terminology? What's the lingo, the jargon, right? And then a real world scenario. What is the, where's the application? Where is it? What is the application for this? And that's kind of like how I like to do things. So I don't necessarily mind Jeremy giving way too much information. And it being maybe like a little bit too high, because I feel like I'm strong enough to understand like how it's built from the foundation upwards. But I also can relate to that. That's not necessarily good for a lot of other people as well. What protocol is used to discover a layer 2 address? ARP. What is the minimum size of an Ethernet payload? Isn't it 18? 46. Dang it. I need to look at that image again. What two messages are used in ARP? The request and the reply. The ARP reply message is a broadcast. No, the ARP reply. Dang it. I gotta read and actually comprehend what I'm reading. What is the broadcast MAC address? The source? Is that what it's wanting? Oh. It wanted the actual address. Okay. That makes sense. What is the command to view the ARP table in Windows Mac? Isn't it ARP-C? ARP-A. What two messages are used in ping?
It's too much information, making the important stuff harder to retain.
I could see that. Ooh. What two messages are used in ping? The send and the receiver? Oh, that's what it wanted. ICMP echo and the ICMP reply. So we have the request and the reply. The ARP request message is a broadcast. The request is a broadcast. Yes. What is the minimum size of an Ethernet payload? Man, I really need to look at that image again that has the whole like thing broken down. Let's look at it real quick. Okay, so we have the Ethernet payload breakdown. We have preamble. We have the destination address, the source address, the type, the data, and the FCS. Okay. Hey, look! It's from CBT Nuggets. So then, what is the minimum size? The minimum size of the payload is going to be 8 plus 6 plus 6 plus 2 plus... That's it, right? So 12, 13, 14, and then 14 plus 18, or 14 plus 8 would be 22. That's not right. There's no way that's right. It's 46. Y is 48 or 46. 46 bytes. Okay, I see here. The minimum Ethernet payload is 46 because the minimum Ethernet frame size is 64. So... Oh, okay. The payload is smaller than the frame. The frame is all of it. Add everything except the payload. Oh, and they're bytes, so it should be multiplied by 8. Right? Maybe the actual payload is only 20, but the Ethernet requires it. So then it puts like padding. Yeah. So add everything. So those are all bytes. So the Ethernet says the whole frame must be less. Okay, so add everything except the payload. Okay, I think I understand. What is this? Whoa, that's new. Whoa, it tracked my... Whoa, so I can go to my different stuff. Oh, that's cool. That's so cool. Okay, anyway. I think I'm starting to understand. Because we have the payload is in the frame. Yeah, and then so well then what's in the frame? Or sorry, then what's in the payload? The payload has something else in it. Packets. It's the packet. Okay. What two messages are used for ARP? The request and the reply. The ARP reply message is a unicast. What is the broadcast MAC address? All Fs. What is the command to view the ARP table? Oh, that's going to be ARP-A. What two messages are used in ping? The request and the reply. And it's ICMP. The process of addresses being cleared from the MAC address table after 5 minutes of inactivity is known as... Isn't it dynamic? Oh, aging. Dynamic is that it does it itself. It makes the table itself. What is the minimum size of an Ethernet payload? The minimum size of an Ethernet payload is 46. The payload, not the frame. Clear all dynamic MAC addresses from the MAC address table. Isn't it no? No, it's literally clear. Okay. View MAC address tables. Isn't it just view MAC? No, view ARP table. No, show. Man, I need to do a better job. What is the minimum size of an Ethernet frame? Header, payload, trailer. Now, this is not just the payload. This is the whole frame. Well, hell, this says 64. It is 64. I'll be damned. What is the size of the Ethernet header and trailer, no preamble, or SFD? $46 plus 6 plus 2? Is that right? So then it would be 6, 7, 8, 9, 10, 11, 12, 52, 54, 18. Oh, because all we did was add it. But we didn't include the... We didn't include the pit. Man, I might need to go back and rewatch that. Clear all dynamic MAC addresses on the table. Oh, excuse me. Tired. I'm getting hungry too. Isn't it clear MAC addresses dynamic? Clear MAC address table dynamic. View the MAC address table isn't it? It's literally view MAC address. Show. Dang it! I did that last time too. It's not view. It's show. What is the minimum size of an Ethernet frame? 64. Clear all entries for the specific MAC address. Clear MAC address table, dynamic address, and then you say the address. What is the size of the Ethernet header plus trailer? No preamble. Didn't we say it was 18? Yeah. Clear all dynamic MAC addresses. So it's literally clear. Is it clear all or is it just clear MAC address table dynamic? Clear MAC address dynamic interface ID. I need to practice some of these. What is the Ethernet type code for ARP packet? I don't know. Oh man. Okay. Clear all dynamic MAC addresses from the MAC address table. Clear MAC address table dynamic. View the MAC address table. Show MAC address table. What protocol is used to discover the layer 2 OARP?
You do a do show when you are in configuration mode.
Do you do a show when you are... Yes. Yes. Well, there are some things that you can hit show and it'll show you in non-configuration mode. There are some commands where you can show the IP address and things like that in just non-privileged exec mode. What is that? Enable, not enable. Just the normal, the baseline. Command to show the ARP table and Cisco devices. Show ARP table? Yeah, show ARP. The ARP request message is... It's a request, so it's going to be uni. No, it's going to be broad. The ARP reply message is a uni.
Do you mean like enable?
Yes, yeah, enable. Like, so the way I think about it with a Cisco switch or like any of those devices is I just think about it in terms of a tree. Like, you get into the switch, right? Like, you put in the passcode, you get into it. And you can only do so many things. And then you got to go a level deeper by doing enable. And then you put a passcode in or something or whatever. And then you can go deeper in different branches based off being in config T or to be in like interface. And then like those branch out. I think of it as like a giant tree. And actually I was thinking about making a graphic of like the commands in the tree and how it like spans down. I know it doesn't necessarily work for all of it, but it does work for quite a bit of it. And so then it kind of is a roadmap with everything. What is the command to view the ARP table? Show ARP. No, ARP, that's no, damn it. What is the command to view the ARP table on Windows and Linux computers and Mac? Not the Cisco device. What two messages are used in ARP? Request.
Do you pay for Claude?
I do actually pay for Claude. I think it's 100% worth it. It is so worth it. Yeah, I can't even begin to tell you how much it's worth it. I even think that if the Fable 5 is in the $200 tier, that it's worth $200. The things that I've done with Fable 5 to just organize for productivity is absolutely insane. Yeah, it's absolutely insane. But to study and stuff, you definitely don't need the $200 version. I would use the paid version. I don't remember what it comes with. I think it comes with projects, so you can kind of organize your threads and stuff. But yeah, I would definitely recommend Claude over ChatbotGPT. And I would, if you have the money, I would recommend to pay the $20 or $30 a month for it. It's definitely worth the extra usage, especially if you're going to use it to study. If you don't have a class or anything, I use ChatbotGPT.
I think.
Yeah, I use ChatbotGPT just as a study thing, but I also use Claude all the time to like make documents, to make PowerPoints. I just ran through all of my financial stuff, like to make a financial sheet to make sure all my formulas were correct.
Grok is funny.
Grok is funny. I do like Grok. I just don't use it a lot, unless I'm like trying to figure out news stuff, kind of thing. But yeah, AI is a 100% extremely powerful tool. Everyone who's upset with it or whatever, they're just afraid of it, and they're upset with the disruption that it has caused, which has been big. Don't get me wrong, and there's definitely negative aspects of it, but the positive gain that I get on the daily is just too high. It's too much. See here, the two messages used in ARP is the request and reply. Same thing, it's request and reply, but it's ICMP. The process of addressing being cleared from the MAC address table after 5 minutes is, oh man, I know this. Inactive. It's not dynamic. I thought it was dynamic, but it's not. Damn it. Damn it, what is it? Show me. Aging. Okay, what is the broadcast MAC address?
They just haven't learned to use AI as a tool.
It's all F's. Yeah, you're absolutely correct. Like, I was working on a video to show like how to use AI as a tool in order for as a teaching tool. Yeah, like it's crazy. It helped me make, because I was trying to make a spreadsheet for my house payment and for my car payment, and I was trying to do like ifs and thans and whatever, and it was taking forever. And then I just explained exactly what I wanted the spreadsheet to do in plain English. I didn't even type it out. I just spoke it into my phone, speech to text, and then it made it for me. And then I took that and I just, obviously it wasn't 100% correct with certain numbers and like the way I wanted it formatted or whatever. And it took me 20 minutes to like fix the format. But then I had a 27 sheet spreadsheet that was all hooked up, all done. And it was all done in probably like maybe 45 minutes. That would have probably taken me weeks to do. You know what I mean? So yeah, you can't be afraid. You can't be afraid of the thing. And you can't be afraid of how the world changes. It's scary. You can be afraid, like you have the right to feel that, but you can't let it rule you. What is the minimum size of an Ethernet payload? 46. Yes. Clear all entries. It's going to be clear. Yeah, clear MAC address. Clear all dynamic. It's going to be clear again. Clear MAC address, dynamic interface ID. What is the minimum size of the Ethernet frame? I always get this one mixed up. 64. Dang. Clear MAC address table dynamic. What is the size of the Ethernet trailer? Isn't it 18? Yes. What is the Ethernet type code for ARP packets? Isn't it 080? Yeah. 2 left. View the MAC address table. Isn't it just show ARP table? Oh, show MAC address table. Okay. Command to show the ARP table on Cisco devices. Show ARP table. Show ARP. Congratulations. Okay. Now, a bunch of these flashcards are me figuring out the IP address or figuring out the binary. I may or may not just kind of go through it. Like, not like fully because I'm tired. I'm getting hungry. I'm not gonna lie. What is the length of an IP address in bits? There's 4 octets, so 4 times 8, right? So 4 times 8 should be 28. 32. Oh, 28 is 7. 7 times 4. 7 times 8. Yeah. That doesn't make any sense to you, but it makes sense in my brain. Okay. What is the length of the IP address in bytes? 4. So then 4 times 8 is 32. Got it. My mouse is about to die. What are the groups of 8 bits? Oh, they're called an octet. These are these are way simpler than the last ones, at least so far. Only two in so far. Okay. What are the groups of 8 bit? Oh, I already did that one. What is the maximum value of binary in an octet? 255? Is that what it's wanting? If it's all ones? Okay, good. What is the numeric range of the first octet? 0 to 126. Dang it. What is the numeric range of the first octet to class B? That is to 191. Yes. I knew that because class C is 192. 192 to 1 2 206 223. Okay, what is the numeric range of class D? I don't care. Like, we don't use class D very often, right? Like, and then class E, I don't know. Maybe those are important and I just don't realize them. But as far as I'm concerned, I've never been asked anything with class D or E. And honestly, I've never really been asked to do anything with class anything. No one's ever come to me and been like, well, we need a class C license or class C IP address. And then this also brings up the same thing that I asked earlier, like in the very beginning of the stream. Like, if we're trying to get away from an age out IPv4, then like, why are we still talking about classes? And why do we use IPv4 for private addresses? Like, is private addressing with IPv4 really that much simpler than IPv6? I don't these are questions I don't really know, you know? And then also at the same time, does the class actually matter anymore? Because IPv4 is mainly used on the daily for private use, for private networks. And if it's used for private networks, what does it matter if I use a class A or a class C, other than the fact that I would like waste thousands of IP addresses? I don't know. What is the binary bit pattern of the first octet? Class A? Zeros to ones? Oh, that's what it wants to know. Okay. I understand. So then it's going to be 0, 0. Or 1, 0. Then 1, 1, 0. Yep. And then 1, 1, 1, 0.
IPv6 has vulnerabilities.
Well, so does IPv4. And a lot of the vulnerabilities that are in IPv4 that have like all these band-aids to like make them better is built into IPv6, or at least that is what it was from my understanding. I'm not saying that IPv6 is like perfect or anything like that, but you know, and I don't want to go down this road 'cause it's not a conspiracy channel. But if we have IPv4 and IPv6 and all of our computers talk to each other, which internet version do you think the government uses? I don't know. Maybe it's 5. Maybe it's 7. I don't know. Think about that. Okay. It's gonna be 1, 1, 1, 1, 0. Yep. Or just 1, 1, 1, 1, 1. What is the class the IPv4 arrange reserved for? Experimental. Oh, multicast. E is experimental. Yeah, this is experimental. IPv4 addresses begin with 127 are used for D. No, used with B as in boy. Loopback. Oh, because it's the end of Class A. IPv4 addresses begin with blank are used for loopback addresses. 1, 2, 1. So that would be 127. But isn't there more?
A lot of gamers and PC enthusiasts will tell you to disable IPv6.
Really? Well, see here. My fat. Oh my god. Dude. See, this is why. Oh, no. Go back. Okay. Does IPv6 have vulnerabilities? And if I use IPv4 for my private network or even. Man. I'm on the struggle bus. Public addressing. Should I be worried or disable IPv6 and just use IPv4? What do we got? IPv4 address beginning with blank. Is it 127? Yeah. What kind of address? This thread's getting way too long. Yes, it can have vulnerabilities, but IPv is not automatically unsafe. For home use, I would not disable IPv6 just because it exists. The better rule is use IPv6 if your router firewall handles it correctly. Disable it if your router does not firewall IPv6 properly or you are troubleshooting a specific issue. The big difference, private NAT router internet. Your device usually has private addresses. Yes. Those are not directly reachable from the internet. Global routing, IPv6 devices, routers, internet. Your device may have real global IPv6 addresses. Oh, so that's why it's a vulnerability, is that my computer, my NIC in my computer might have like a legitimate public IPv6 address, which means that it's exposed to a lot of things versus it only going through my router. That's interesting. I didn't know that. Interesting. It's suggesting that NAT is a safety feature, not necessarily that it was designed for a safety feature, but it kind of is like a safety feature because it all goes through the gateway. And I'm pointing back there because that's where my rack is. Does my router block unsolicited inbound IPv6 traffic? Interesting. I would hope so. So let's say your home PC is this and it's this. Your IPv address is private, so the internet cannot directly route to it, but your IPv6 address may be. So may be global. So then how do I know? That's also like really irresponsible. I know that we have like a crap ton of IPv6 addresses, like public addresses, but like that's how we ran out of the internet back in like what was it, like 2008 or whatever, because we ran out of all the IPv4 addresses. So how do I know if my IPv6 is a public / global? Where is it? Global address. All right, we'll do a few more. Okay, what kind of address is used to test the network software stack on the local device? What kind of address is used to test the local network stack?
You learn something new every day.
True. Oh, loopback address. Interesting. I feel like he didn't talk about that a lot, but I also was stopping a whole bunch. You can tell your IPv address is public or / global routing if the global unicast address from your home user, a global routable IPv6 address starts with a 2xxx or a 3xxx. More technically, global IPv6 addresses are in the range of this. That means address beginning from roughly this through this are generally global. Oh. Well. I kind of want to look at mine now. Very interesting. Very, very interesting. Okay. So what kind of address is used to test the network? Oh, it's a loopback address. What is the length of the IP address in bytes? It's 32. Oh, bytes, not bits. 42. 4. Damn it. What is the numeric range of the first octet in class B? 10. Oh, no, it wanted its range. Damn it. 128 to 192. 191, because 192 is C. What is the length of the IP address in bits? That's 32. What is the maximum value of binary octet? 255. What is the numeric range of the first octet in D? I don't know this one. I don't know this one. I don't care. I hope it's not on the test. What are the groups of the 8 bits in a IP octet? Yeah, okay. What is the numeric range of the first octet? 0 to 126. 127. But 127 is a loopback, so for whatever reason, that one's special. Okay. I don't care about this one. 192 to... I think it's 224. 222. Or 223. What is the prefix licks? Prefix, that's going to be 0. No, /8, because it's the first octet. Okay. This is the prefix. This is the side R, which I don't know if I ever say correctly. What is the binary bit pattern of the first octet of the class C? What is the binary pattern? Oh, 1 1 1 1 1 at 1 1 0 0 1. Damn it, 1 1 0. That one's gonna be 0 1. Damn it, I'm saying it backwards. What is the prefix length of that? The prefix length 16. 4 8. No. 24. What is the net mask of a /8 prefix length? Oh, okay. What is the binary pattern, bit pattern of the first octet of class E? Oh, the 1111. What is the bit pattern of the first octet? 0. 255, 255? Yep. What is the net mask of that? Would be 255, 255, 255. Yep. What is the host portion of IPv4 address? Is all zeros. What kind of address is that? If the host portion of the IPv4... Oh, it's the network. It's the network address. What is the binary bit pattern of the first octet? I get these confused. I'm starting to get them confused. Okay. So that's the binary pattern. It's the addressing range reserved for. It's not experimental. What's it reserved for? Multicast. What is the E that's experimental? IPv4 addresses beginning with 127 are used for damn it, I knew it right before. Loopback. If the host portion of the IPv4 address is all ones, what kind of address is it? An E? Oh, broadcast. See how I get confused? IPv4 addressing beginning with blank are used for loopback 127. We're almost done. IPv4 address beginning with... Oh, we already did that one. What kind of address is used to test the network software stack? Oh, this is the one I had no idea on. Loopback. Loopback tests the network stack. What is the prefix length of class B IPv4? That'd be 11. No. Prefix length. Dang it. That'd be 8. 24. $255. Yes. What is the net mask for? That'd be 255. 255. If the host portion of the IPv4 address is all zeros, then it's broadcast network. No, it's a network address. If the host portion of the IPv4 that is multicast. No, that's the broadcast. Dang it.
I used to get broadcast and multicast.
Yeah, I also think that I've been going at it for a long time, and I'm starving. So I'm glad that we're finished. So that's it for the study session. I appreciate everyone who stuck with me for the whole thing. Thanks a whole bunch, Cool, for hanging out. I really appreciate you. If you enjoyed the stream, if you liked it, tell a friend, share it, subscribe to the Tyler Lamont channel. That's where all my tech stuff is. If you like that stuff, if you like video game stuff, then you subscribe to Paradiddle Pete. We will be gaming tomorrow at 8 p.m. We're going to finish High on Life, or at least we're going to do another installment of High on Life 2. And then we're going to study again on Wednesday, and then we'll be another gaming stream on Thursday. So that means study streams are Mondays and Wednesdays at 8 a.m. And then gaming streams are Tuesdays and Thursdays at 8 p.m. So if you have any of that stuff, any of that stuff, you want to do that stuff, go check it out. Here's my channel. Please give it a subscribe. Wow, a lot of people subscribe. Thank you. Wow, did not expect that. So anyway, that's all I got. Remember, work with what you got, build what you need, and I will catch you in the next one. Later.